Thank you so much, Kennedy, for joining me. Welcome to the HIV Cure podcast, where we just want to get more information when it comes to the latest of what's happening with HIV Cure and just breaking it down using simple community language.
Yes, thank you so much for having me on your podcast.
And I just want to get to know you a little bit more. Please tell us about yourself and how you ended up having that interest in HIV cure.
Yes, I'm a long-term activist. Um, I've been an activist for many years, um, 30 years in activism. So over the years, I got interested in basic science. We used to call it treatment literacy then. Then I just got interested in research later on in my journey as an activist. So mm, recently, about 5 years ago, I now got immersed in HIV cure research literacy, which also culminated into me being selected as an International AIDS Society HIV Cure Research Academy, which was held here in Botswana. Then I'm also an International AIDS Society Cure Grantee 2023. So so in a nutshell, I think that's what pushed me into this space. If you're a long-term survivor, I think what you need to have done all the science, basic science. Now it's time to really push my head and try to see if we can push for a cure for HIV. In a nutshell, that's what brought me here. Thank you.
All right, that's very interesting. Like you've been doing quite a lot when it comes to HIV, and I love how you've also just kind of like let us in on how the HIV Cure Academy sort of like started and how it was here in Botswana, because a lot of people don't know much about that. They always just think that when it comes to HIV cure, we think South Africa and other countries. And I love that you let us in on how it came about in Botswana. And we also want to just know about what is happening, because a lot of people also say that no, these people are hiding a cure from us. It's there. And yeah, because that's what a lot of people say. They're like,
Yeah.
no, they're hiding it from us, especially us in like in Africa. They're hiding the cure from us, and now we just want to know and really unpack that is there really a cure. I think let's just start from there, even though we're going to be talking a lot, just so that people know what is happening.
Yeah, we do not have a cure yet. We don't have a scalable cure yet. Most people that have been reported cured of HIV, um, they were initially being treated for cancer. Those cases of ovarian patients, lung patients. So that strategy that were used in research is just it boosts the researchers' morale to say, look, we can still perhaps replicate this and use it in real world, cure strategies. So there is no cure. So by the way, it's only treatment that is available now. So the cure is not there. No one is hiding the cure. We just don't have a breakthrough in achieving a cure yet.
All right, thank you for just clearing that out. And you also said that we are working towards a cure, that what we have is currently not scalable, and which means that we do have something that is sort of like it's tangible. We're working towards something, and there are also different strategies that the scientists are using when it comes to HIV cure, and one of those is the bNAbs, the broadly neutralizing antibodies, which is what we're going to be talking about today. And we've also learned that HIV is a virus and that we can't be using antibodies to treat it. But now we're talking about broadly neutralizing antibodies. So we just want to know, how are these antibodies so special that all of a sudden we're saying that they can actually work on HIV?
Yes. So let me begin here. So broadly neutralizing antibodies, or bNAbs, are just a unique class of antibodies, with extraordinary abilities to target and neutralize a wide, variety of HIV strains. So let me break it down. So this stands for broad, meaning these antibodies can act against a broad spectrum of HIV variants. Okay. Then the N is for neutralizing, which reflects, the ability to block the virus from infecting human cells. So finally, the ABS, is simply a shorthand for antibodies. Okay, so these are proteins produced by our immune system to fight infections. In a typical HIV infection, our immune system produces antibodies that are often too specific. Okay, so they may neutralize one strain of HIV, but fail, against others due to, the virus high mutation rate. The virus mutates rapidly. So in contrast, what bNAbs do, they target conserved regions of the virus. Those are parts that don't change during the mutation process much. So across different strains, HIV strains, making them far more, versatile. So this, in a nutshell, this is how I can explain what bNAbs are.
And now that you've explained a bit on how they work, we want to know how effective they are when it comes to targeting HIV, especially given that this virus has the ability to keep mutating all the time when it comes to, or when it invades the body.
So yeah, so HIV notorious, very notorious. Okay, I'll use the word notorious for its ability just to mutate rapidly, creating a highly diverse, swarm of viral variants within just a single person. Okay. So, however, bNAbs are effective because they recognize and bind to those conserved regions of the HIV envelope. Okay, the outer shell of the envelope. These are areas of the virus, that are critical for its ability to infect cells and are less likely to mutate. Okay. So by locking onto these conserved sites, bNAbs essentially freeze, the HIV's ability to adapt or evade the response. So this precision target is what makes them such a promising tool in the fight against HIV.
Oh, you mentioned about HIV's diversity, and now my question is that then why is the HIV diversity such a major challenge for treatment as well as vaccines? And then how do now bNAbs come in to help overcome this challenge?
So HIV diversity is one of the biggest hurdles, in developing universal treatment and vaccines. We know if we've been following, research in that space. So we saw many different strains, circulating globally, and even within a single individual, it's incredibly challenging to design therapies that work against all of them. So traditional vaccines aim to train the immune system to fight a specific version of the virus. But HIV constantly, the evolution outpaces, these efforts. So bNAbs tackle this diversity head on by targeting the virus, conserved regions. So their ability to neutralize a wide, array of strains means they are a universal approach to HIV treatment and prevention. This also bridges the gap that current therapies and vaccines struggle to address.
Okay, so it seems, from your explanations, these bNAbs, these are like the smart antibodies when it comes to just treating infections, or particularly HIV. But are there any limitations when it comes to these using bNAbs? Are there any limitations or weaknesses on how they work?
Yes, that's a good question. So we know that while bNAbs are seemingly a game changer, they are not perfect. Okay, some HIV strains
Mm-hmm.
may have mutations even in those conserved regions that I talked about. Those are regions of HIV that rarely mutate, so making them resistant to certain bNAbs. Okay, so additionally, the virus can
Okay.
sometimes escape bNAb pressure by making vulnerable sites with sugars called glycans. They call glycans, which can block the antibodies from binding effectively. Moreover, the natural production of the nuts in the body is rare and takes years of chronic infection to develop. So scientists are addressing these limitations by engineering combination of bNAbs to enhance their breadth and potency, ensuring that they cover as many HIV strains as possible. So you can see that at this stage, it has also limitations, though it's promising.
All right. Thank you so much for that explanation. So then, how are bNAbs being used in the current HIV treatment strategies, and are they seen as a potential to replace ARVs?
Wow, I'll be happy when we arrive, when we cross that, when we finally cross that bridge. Yeah. So currently, the maps are being explored as both standalone treatments, okay, where
Okay.
they will just be used on their own, and in a combination with ART, okay. So unlike ART, which suppresses HIV replication using small molecules, broadly neutralizing antibodies work by neutralizing the virus cell and tagging infected cells for destruction by the immune system. So while bNAbs show promise, okay, while they show promise, they are not yet a replacement for ART due to their relatively short durability in the body. They require periodic infusions, okay, and injections. However, ongoing research
Okay.
actually aims to extend their lifespan, making them a potential, no, I'm happy, making them a potential long-term alternative or complement to ART.
Okay, so you also talked about vaccines when you're talking about bNAbs, and now I'd like to know the role of these bNAbs when it comes to HIV prevention, and how effective are they compared to the existing PrEP, like the oral PrEP versus bNAbs?
Wow, great question. So broadly neutralizing antibodies, for sure, they could revolutionize HIV prevention. Okay. Studies have shown that administering bNAbs to HIV-negative individuals can block infection, just much like pre-exposure prophylaxis or PrEP. One advantage of
Okay.
bNAbs over PrEP is that they have potential for longer-lasting protection. So a single injection, for example, could provide immunity for months. Okay, that's another advantage. However, challenges remain, such as ensuring that bNAbs can neutralize circulating strains in different geographic regions. They are also not yet as accessible, as practical as daily PrEP, but their
Okay.
potential for sustained protection makes them as an exciting option for the future. So that's why they're in the pipeline. There are several research projects looking at using bNAbs for prevention.
Okay, so just to entice us, earlier on you mentioned that bNAbs versus ART, that the reason why we cannot be replacing it is that with bNAbs we need like constant infusions, and they have like a short lifespan. But now when we're talking about bNAbs versus PrEP, you mentioned that they have a longer effectiveness. So how long is long versus daily oral PrEP?
So in some instances, they're being explored for up to 6 months to 1 year, some studies. So
Oh
yeah,
wow,
so
okay.
that's a better option. Daily pills, usually, we know the uptake of PrEP has been a big challenge, especially among adolescents.
Yeah.
So bNAbs would actually bridge that gap.
Okay, wow, that's amazing. I hope that we get to
So that,
see
yeah.
and experience them. And now, then, how do these bNAbs now contribute to? Because now we're talking about PrEP that bNAbs they take up to 6 months to 12 months. So then, how can we use this advantage, or yes, this advantage to contribute to the development of HIV vaccines?
So in vaccine development, so broad neutralizing antibodies are just a blueprint. So scientists are studying how individual naturally, develop bNAbs after years of infection, are trying to, replicate the process through vaccination. So the goal is to train the immune system to produce bNAbs in response to a vaccine, for example, providing long-lasting, immunity. So bNAbs are a game changer. bNAbs are a game changer because they offer a clear target for vaccine design instead of shooting in the dark. So researchers now have a roadmap to follow, developing, vaccines that elicit these powerful antibodies.
All right. Thank you so much. And then you mentioned that when it comes to bNAbs, there are some challenges that are there. So can you please just share with us these challenges that researchers are facing and that are facing when it comes to now making bNAb therapies available for the public as well as especially the regions that are most affected by HIV?
So one of it is cost and infrastructure. Okay, those are a significant hurdle. Okay, producing labs requires sophisticated biotechnological processes. So making
Yeah.
them more expensive, yeah,
Hmm.
they make them very expensive to manufacture. Additionally, delivering these therapies to resource-limited settings where the burden of HIV is highest requires overcoming some logistical challenges such as cold storage, regular healthcare access for injections, etc. So researchers are working to simplify production processes and develop bNAbs that remain stable at room temperature, and which could make them more accessible globally.
All right. That's very interesting, especially that we're looking into like countries in like African countries. We find that we don't have a lot of resources and all these
Yeah.
things. And also now, my question is on the advocacy side. So, what role do advocates now have when it comes to making sure or knowing what to advocate for after learning about this game changer when it comes to bNAbs and HIV prevention and the potential for women?
So the role of advocates is to continue, advocating for domestic resources. Most of these projects are really externally funded by global consortiums that are not even based in high burden countries like ours. So activists should begin to engage, local resources, engage and lobby for political uh, willingness so that we can be able to begin to
Yeah.
develop our own bNAbs in Africa.
All right. Thank you so much. The reason why I bring advocates in is because a lot of them think that when it comes to these, it's too scientific for them, and only the scientists should be the ones that are making sure we get these therapies or these game changer treatments and preventions that it's too technical for them. They can't be in the space, and or they think that there is nothing for them to do when it comes to advocating for a cure or advocating for something that is a bit it's too science for them. So that's why I'm bringing it up so that you can also share and just show them the options that they have and the spaces that they can go into.
Yeah, all this was begins with raising the the literacy, the health literacy or research literacy levels
Yeah.
among, especially people living with HIV, because you can only advocate for something that you know. So as much
Yeah.
as these are promising interventions, if the majority of people living with HIV, for example, are not aware of these efforts, they will stay away and talk about them because they are not aware of them. So this is a time I can take the science to the community. Let people know what is happening, what is in the pipeline, how far are we, what are the challenges in achieving the cure, for example, and they have to understand the science. You can't. This time there is no activists who can shun science. We have reached a critical stage in advocacy that we all need to know the basics. So let's take science to the people, like through this podcast.
Yes, thank you so much. And you are listening to this podcast, and I hope that you see the options that you can play as an advocate when it comes to HIV cure. And just to close it off, Kennedy, we talked about the challenges that the scientists are going through, and how now are these scientists working towards improving the durability as well as the potency of bNAbs to make them more effective for long-term use. Like you talked about that they can work for 6 months, and then how are they working towards making it work for a year or even potentially more than that?
Yeah, so scientists are actually employing advanced, bioengineering techniques, to enhance the half-life of bNAbs, meaning they stay active in the body for longer periods. So this involves actually modifying the antibodies or the antibody structure to make it more resistant to degradation, so that it stands for a long time, it exists for a long time in the body. And additionally, researchers are also, combining multiple bNAbs into what we call cocktails, just to increase their breadth and effectiveness. So these combinations reduce the likelihood of HIV, developing resistance and offer a more comprehensive shield against diverse strains.
All right. Yeah, you said a mouthful there, but we understand. We're getting educated. The science is going in. We are digesting everything, and now to sort of like close it off. What are some of the or what are the next big milestones that researchers are aiming for when it comes to um, bNAbs development, and how could these impact the global fight against HIV?
So the next milestones, I think, will include developing affordable, long-lasting bNAb formulation and integrating them into combination therapies with ART. Okay. So another key goal is achieving success in vaccine trials that can, elicit bNAbs naturally in the body, making HIV prevention widely accessible. So if these milestones are met, my belief is that bNAbs could, significantly shift the trajectory of the HIV epidemic, providing new tools for treatment, prevention, and ultimately a functional cure. I like to use the word functional cure. So the global fight against HIV, the global fight against HIV could enter really a new era of innovation and hope.
Yes, all right. Thank you so much for explaining and talking about how, access is a very crucial step when it comes to having this functional cure and making sure that everyone is able to access it, and also that when it comes to access, we have long term that I only need to just have an infusion once, and it can last me for a very long time. It's something that I hope it will happen in my generation And in an era way, I'm able to come back to say, remember that episode that we talked about with Kennedy. So thank you so much for joining me, Kennedy.
Thank you so much, Sekabo. Please feel free to reach out again. This has been an
Yes, I'll
interesting
definitely.
session, and please, I applaud you for this. This is one of making sure that the science is reaching the people. Thank you so much again for having me on this program.
Thank you, Kennedy, and thank you so much for tuning in. And I hope that you got to understand a little bit about bNAbs, where we currently stand with bNAbs and HIV cure, where we're going, and our hopes and just dreams to seeing a very functional cure for all of us across the world when it comes to access and equity. I'll see you all tuned in next time as we dive into another episode of HIV cure. Thank you so much and bye.
Bye bye.